Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about polar form of complex number or trigonometric form of complex number. Before we begin that, let's just quickly go over what a complex number is and some operations on a complex number. So a complex number is any number written in the form a plus bi, where I is an imaginary number. So I equals square root of -1. So that's what I means. So if a complex number is written in the form a plus bi, a is called the real part and b is called the imaginary part. Now, to add and subtract a complex number, it is just like adding and subtracting binomials. So if we have a plus bi and c plus di, two complex numbers, and if we are adding them, so when we add them, we just add the real parts, a plus c, and then we add the imaginary part, which is b plus d. Same thing with the subtraction. We subtract the imaginary part and we subtract the real parts. So let's look at some examples. So here we are going to add and subtract. So in order to add, what we're going to do is we're going to do 2 plus -3, which is -1, and then 5i plus -4i, which is just minus I. So it's -1 minus I. Now, here the same thing. When we have subtraction, it might be easier to open the parentheses and then combine the like terms. So -2 minus 7i minus 2i, and that gives us -2 minus 9i. Now multiplying a two complex number is again same as multiplying binomial. So we can just distribute or we can FOIL. So we'll multiply a times c, a times di plus bi times c and bi times di. So it's just like multiplying binomials. So there's one difference here because whenever we get I squared, we need to remember that is -1. So we have to replace I squared with -1. So let's look at examples here. So to multiply this, we are going to do the distribution. So 2 times 2, 2 times 4 is 8, plus 2 times -5. So let me write minus 10. And then we have 3 times 4, 12, and we have that I. Then 3 times 5, so -15. Then I times I is I squared. So we have 8 minus, so this is 10i. So 10i, -10i plus 12i is plus 2i. Then we have -15 or minus 15. Then I squared is -1. Now what happens here is we have 8 plus 2i plus 15, and that gives us 23 plus 2i. Similarly here, when we multiply this, we get 2 times 2 is 4. 2 times -5 is -10, and then we have I. So 5i times 2 plus 10i. Then 5 times -5 is -25. Then I times I is I squared. So that gives us 4. So -10i plus 10i is 0. So minus 25 times I squared is -1. So we get 4 plus 25, which is 29. So that's how we multiply complex numbers. So there's something called conjugate pairs in complex numbers. So any complex number of the form a plus bi will have a conjugate which has a form a minus bi. So the only difference here is the sign is negative. Okay, so for example, if we have 2 plus 3i, the conjugate is 2 minus 3i. Or if we have -5 minus 7i, the conjugate is -5 plus 7i. So the only thing that changes is this sign, okay? Everything stays same. Now, when we multiply conjugate pair, complex conjugate pair, it's very interesting that if we have a plus bi times a minus bi, that's the conjugate pair, then the product is a squared plus b squared. Let's look at the example that we had earlier. So this one if you look over here, this is a conjugate pair, okay? So we have 2 plus 5i and 2 minus 5i, so it's a conjugate pair. So if we use that multiplication, okay, if we use this one, the multiplication, the product of conjugate pair is a squared plus b squared. If we use that, then this is 2 squared plus 5 squared, which is 4 plus 25 equals 29. That's what we have here. So that's how easy it is to multiply conjugate pair, and that's only true for conjugate pair. Now, next one is dividing complex numbers. So when we are dividing complex number, first we would like to write as a fraction. So if you are dividing 2 plus 3i by another complex number, we write this over that one. Okay, so the dividend by divisor. So we write as a fraction. And the next thing that we do is we multiply both numerator and denominator by the complex conjugate of the denominator. So we will find the conjugate of the denominator and we multiply both numerator and denominator. And the next thing is we are just going to simplify it. Let's look at an example. So here we are going to divide 2 minus 3i by 3 plus 4i. So the first thing that we are going to do is we'll write this one as a fraction. So 2 minus 3i divided by 3 plus 4i. Now the next step is we will multiply by the conjugate of the denominator. So 3 minus 4i is the conjugate of 3 plus 4i. And then we multiply the numerator by same thing. Okay. Now let's go ahead and multiply and simplify. So when we multiply the numerator, 2 times 3 is 6, minus 8i, minus 9i, plus 12i squared over, so denominator is the conjugate, so the product of the denominator is 3 squared 9, plus 4 squared is 16. And in the numerator we get 6 minus 17i. This is I squared is negative 1 times positive 12 is minus 12 over 25. So 6 minus 12 is negative 6 minus 17i over 25. We don't leave it this way. When we write the complex number in standard form, we write a plus bi. So we'll split this fraction. We're going to write negative 6 over 25, which is a. Then plus, or we can just write minus 17 over 25i. So this is in that standard form. So that's how we write it in the standard form. Now we can graph the complex number. So graphing complex number, we don't use the Cartesian real coordinate. We will use the complex coordinate where instead of x-axis, we have real axis, and instead of y-axis, we have imaginary axis. So any complex number a plus bi. So when you look over here, the real part is this x-axis represents the real part, and then the y-axis represents the imaginary part. It's the same as saying if you have a plus bi, it's a comma b. This is x and this is y. If you think this is x and this is y, okay. So it's same as plotting any point x comma y in the Cartesian coordinate system. Is very similar here, okay. So let's go ahead and grab the first one. So we have 3 plus 4i. So the real is 3. So 1, 2, 3 here real. And then complex is, the imaginary is 4. So we go up 1, 2, 3, 4. So this is the point. And then we do draw a line from the origin to represent that complex number. Okay, so 3 plus 4i. So that is the first number. Then the next one that we have here is 2i. So we don't have real part. So real part is 0. Imaginary part is 2. So we go from 0, we go up 2. So it's right here. So we will use this arrow to denote that. So this is 2i. Now the next one is negative 5. So the real part is negative 5 and we don't have imaginary, which is 0. That means right here. So this is negative 5. Okay. And the last one is negative 2, negative 3. So the real is negative 2, 1. So it's right here. So 1, 2 here. And then we go down 3. 1, 2, 3. So this is the number, which is negative 2 minus 3i. So it's very simple to graph it or plot those complex numbers, where you can just treat this as x and this as y in the Cartesian coordinate system, and it's very similar pattern here, okay? Now we are moving into the real topic that we are going to talk here is we can write any complex number a plus bi in polar form, or it's also called trigonometric form, okay? So when we write a plus bi, this is usually called standard form, and then sometimes it's also called rectangular form, okay? Whereas this is called the polar form, okay? So it's very similar to the polar coordinate that we discussed in the previous video. That's why it's called the polar form. So it comes from here. So for example, if this is the real axis, this is the imaginary axis, and we have, let's say, a and b. So this complex number a comma a plus bi is right here. So it comes from here. Okay, so if we complete the right triangle, so this is B, this is A, this is theta. So we get R is this length, R equals A squared plus B squared, and the square root of that, which comes from the Pythagorean theorem. And then tangent theta equals B over A. So it just comes from here, okay, from the graph of the complex number. So the polar form is this one. So the one that we have here. So r times cosine theta plus I sine theta represents the polar form. Okay. So because from here, if we find cosine theta, we get a over r, and then if we multiply by r, we get a equals r cosine theta. That's why we replace a with r cosine theta, and then similarly we can find sine theta, and which gives us b equals r sine theta, and if we factor out r, then that's what we get. Okay, so let's look at some of the examples here. We'll first do the conversion from polar to Cartesian, and Cartesian to polar to rectangular, and rectangular to polar form. Okay, so the first one, we are going to change this into trigonometric or the polar form. So when we do that, what we need is we need angle, and then we need uh, r. Okay, so first here what we have here is a plus bi. So it means a equals 1 and b equals -1. So that means r equals square root of a squared plus b squared, which is just square root of 2. Now to find theta, we use tangent theta equals b over a, which gives us tangent theta equals -1. So we know that tangent is negative in the third and the second and the fourth quadrant. But now, which angle do we take? Do we take the angle in the second quadrant or fourth quadrant? So what we have to do is we have to look at the graph of this complex number. So when we look over here, the imaginary part is positive, so it's 1 here. Sorry, the real part is positive, which is 1 here, and the imaginary part is negative, so it's down here. Okay, so our complex number is right here. That means it is in the fourth quadrant. So tangent theta equals -1 in the fourth quadrant if theta equals 7 pi over 4, or if you are writing in degrees, it is 315 degrees. Okay, so now we can write this complex number in the polar form. So let's write it here. So this complex number in the polar form is, let's say it's z. Okay, so z equals r. So r is square root of 2 times cosine theta. So let's write 7 pi over 4 plus I sine theta 7 pi over 4. We can also write it as square root of 2 using degrees, so we can write 315 degrees plus I sine 315 degrees. So either one is okay. Okay, we can write that or this. Similarly, let's look over here. So r equals square root of 3 squared is 3 plus 1 squared is 1, which is square root of 4. That means r equals 2. Now tangent theta equals b over a, so b is 1 over square root of 3. So we know that tangent theta is 1 over square root of 3 when theta equals pi over 6 or 30 degrees. Okay, so that means the complex number is r, which is 2, then cosine theta. So we can either write cosine pi over 6 or 30 degrees, so it's up to you whichever you want to use. So and I sine pi over 6. Okay, or you can also write 30 degrees if you want. Now let's do the opposite. Let's convert this complex number. They are given in the trigonometric or polar form, so we are going to write them in standard form or the rectangular form. So for that, we just need to find the value of these trigonometric functions, and we'll get the answer. Okay, so here 2 times cosine 30 degrees is square root of 3 over 2 plus I sine 30 degrees is 1/2. Now if you distribute this 2, we get square root of 3 plus I. Okay. Similarly here, square root of 2 times cosine 5 pi over 4 is negative square root of 2 over 2 plus I times sine 5 pi over 4 is again negative square root of 2 over 2. And then if we distribute this negative square root of 2, we get negative 2 over 2 minus 2 over 2I, which is negative 1 minus I. Let's look at another example here. So the next one is, if we are given the complex number in polar form or trigonometric form, then how do we multiply and divide? So that's what we are going to look at. So for example, we have two complex numbers. The first one is z sub 1, which is r sub 1 times cosine theta sub 1 plus I sine theta sub 1. And the other one is right here. So if we are multiplying them, this is what we do. So the product of those two complex number is given by the product of this R, so R1 times R2 times, now cosine, we add the angles if we are multiplying. So theta sub 1 plus theta sub 2 plus I sine, same thing. If we are dividing, we do exactly a similar thing, but what we are going to do is instead of multiplying here, we'll divide R. So we'll divide the R of the first one divided by R of the second one, and then we will subtract the angle. So theta 1 minus theta 2, same thing here, okay? So let's look at an example. Let's go ahead and multiply this. So we are multiplying 3. So let me rewrite this, okay? So we have, 3 cosine 50 degrees plus I sine 50 degrees times 4 cosine 10 degrees plus I sine 10 degrees. So when we are multiplying, what we do is first we'll multiply this R1 and R2. So 4 times 3 is 12. And then cosine, we add the angle. So 50 degree plus 10 degree, which is cosine of 60 degrees plus I sine 50 plus 10, 60 degrees. Okay, so that gives us 12. So we are asked to write the answer in the standard form. If you are not asked to write the answer in the standard form, if you want to leave it in the polar form, this is our answer. But we are asked to write in the standard form, so we are going to write this in the standard form. Again, you already know how to do that. We just find the value. So cosine 60 degrees is 1/2 plus I sine 60 degrees is the square root of 3 over 2. So when we distribute that, we get 6 plus 6 is square root of 3I. Let's look at another example. Again, we are multiplying here. So let me just say this is Z1, Z sub 1, and this is Z sub 2. So I'm just going to write Z sub 1 times Z sub 2 equals, we'll multiply R, which is 12, then cosine pi plus negative pi over 2, which means pi minus pi over 2, plus I sine, same thing, pi minus pi over 2. Okay, now we are going to write this in standard form. So cosine pi minus pi over 2 is just pi over 2 plus I sine pi over 2, and then 12 times cosine pi over 2 is 0 plus I sine pi over 2 is just 1. So when we multiply, we get 12I. Okay, so that's the answer for that. Now we are going to divide. So when we divide this, so let's say again this one is z sub 1 and this one is z sub 2. So if we are finding z sub 1 divided by z sub 2, that's what we are going to do. We'll first divide r, so 4 over 8. 4 divided by 8. And then we have cosine. So when we are dividing, we subtract the angle. So we have 3 pi over 2 minus pi plus I sine 3 pi over 2 minus pi, and then close it. So this is 1/2 cosine 3 pi over 2 minus pi is just pi over 2 plus I sine pi over 2, and then 1/2 cosine pi over 2 is 0 plus I sine pi over 2 is 1. So when we distribute, we get 1/2 I. Now the next thing that we are going to do is we are going to find the power of complex number. So there's a theorem which is called De Moivre's theorem, so which allows us to find the power of a complex number. So for example, if this is a complex number right here, sorry, this is the complex number right here, then the nth power of that complex number is given by z to the nth, or what we actually do is when we are finding the power, if the so we first write the complex number in polar form, okay, a trigonometric form. Then we take the nth power of r, so which is r to the nth times cosine, then we multiply the theta, the angle, by n. So that's all we do, okay. So let's go ahead and do this one. So this r equals, so 4 cube, we take r to the n, then cosine, so we multiply this angle by 3. So 60 times 3, 180 degrees, plus I sine 60 times 3, 180 degrees. That's what we do. So let's write the answer in the standard form. So 4 cubed is 64 times cosine 180 degrees is -1 plus I sine 180 degrees is 0. And then if we distribute this, we just get -64. Now for B, first what we need to do is we need to find we need to write the complex number in polar form, and then we can use the De Moivre's theorem to find the power. So first what we need to do is we have to write this complex number in the polar form. So let's go ahead and do that. So let's go ahead and find R, which is square root of 1/2 squared, which is 1/4, plus square root of 3 over 2 squared, which is 3/4. And that gives us a square root of 4 over 4, or just 1. So r equals 1. Now we need to find theta, so we do tangent theta equals b, negative square root of 3 over 2 divided by 1/2, and that gives us tangent theta equals negative square root of 3. So again, tangent is negative in the second and the fourth quadrant, so we need to check which quadrant is this angle in. So we have the real part positive and the imaginary part negative, so it is in the fourth quadrant. So tangent theta equals negative square root of 3 in the fourth quadrant when theta equals 5 pi over 3. Okay, so that is the angle that we have, or 300 degrees if you're writing this in degrees. Now we have the theta and r, so let's go ahead and rewrite this complex number as, so it's r times cosine 5 pi over 3 plus I sine 5 pi over 3. So this is that complex number, and we are taking the power of 4. So 1 to the 4th is just 1. Then cosine, so we do this angle times 4, so which is 20 pi over 3 plus I sine 20 pi over 3. Okay, and then if we write this in the standard form, so we can find the coterminal angle for this one and use the unit circle. So 20 pi over 3 is same as 2 pi over 3. Okay, you can check by finding the least positive coterminal angle, which we did several weeks ago. Okay, so now this is same as 120 degrees if you just want to think, if you find the coterminal angle. Okay, so or 2 pi over 3. So this is negative 1/2 and then plus I. So sine 20 over 3 is negative, sorry, positive square root of 3 over 2. Okay, sorry, this was, yeah, This is right. It's positive square root of 3 over 2. So now what we have is we have negative 1 half plus square root of 3 over 2 I. So that is the fourth power of this complex number. Now the final thing that we are going to do is find the root of a complex number. So we are given a complex number right here. We want to find the nth root. So nth root could be square root, cube root, fourth root, fifth root, whatever root we want to find. So this is the formula. Sometimes you might, I like to rewrite this as z sub k equals nth root of r cosine alpha k plus I sine alpha k, where alpha k equals theta plus 2 pi k over n. So we'll just write this as alpha k, okay? First, so we'll find these angles and then we'll write the root. So where k equals 0, 1, 2, all the way to n minus 1, which means if we are finding a square root, so n equals 2, so the k is 0 and 1. If we are finding cube root, n equals 3, so k, the values of k are 0, 1, and 2. If we are finding fourth root, n equals 4, and k are 0, 1, 2, and 3. So that's how we find the root of k, okay? And one more thing, if your angle is given in degrees, we don't use 2 pi. So instead of writing theta plus 2 pi k, if the angles are given in degrees, we write theta plus 360 k, because we know that 2 pi means 360 and over n. Okay, so you really need to be careful in that case if your angle is given in degrees. Now let's go ahead and find the cube root of this complex number. So the first thing is we are going to find r and theta. So that's what we need when we find the root. Okay, we need r and we need the angle. So or you have to write the complex number in polar form. We really don't have to write that in polar form, but we still need r and theta. Okay, so let's go ahead and find r. R is the square root of a squared plus b squared, which is square root of 16, and that is 4. Okay, so that is r. But what we need is we need the nth root of r, or here cube root of r, which is same as saying cube root of 4. So this is what we are going to use. Now the next thing we need is the angle theta. So we know that tangent theta equals b over a, or which is just square root of 3 here, and that gives us theta equals 60 degrees. So if you are using degrees, if you are using radians, then this is pi over 3. So we are just going to go ahead and use the degrees, but if we can also use the radians, okay? Now the next thing that we are going to do is, so our n is 3 because it's a cube root. That means k, the values of k are 0, 1, and 2. So it is 0, 1, all the way to n minus 1. So now let's go ahead and find the first angle, alpha sub k, where we use 0. So alpha sub 0 equals, so the formula is alpha sub k equals theta plus 2 pi k over n, or theta plus 360 k over n. So we are going to use degrees here, so we'll use this second one, okay? So theta angle is 60 degrees plus 360 times, the first k is 0 over 3, which gives us 20 degrees. Now alpha sub 1 is 60 plus 360 times 1 divided by 3, which gives us 140 degrees. Alpha sub 2 equals 60 plus 360 times 2 divided by 3, and that gives us 260 degrees. Now if you write this in radians, so the first one you are going to get pi over 9, this is, for this one you're going to get 7 pi over 9, and for this one you're going to get 13 pi over 9. You can also do in radians, okay? I'm just going to show you in degrees, not in radians. Now let's go ahead and list the roots. So the first root, z sub 1 equals, so remember the formula is nth root of r times cosine alpha 1 plus I sine alpha let's say right alpha k, okay, alpha k, because that's this angle. So this, if we go back here, so this is alpha k. So that's what I'm talking about, okay. Now, which means the first one is the third root of 4 times cosine. So the first angle is 20 degrees plus I sine 20 degrees. So that's the first root. The second root is again cube root of 4 cosine of the second angle, which is 140 degrees plus I sine 140 degrees. And the third one is cube root of 4 cosine 260 degrees plus I sine 260 degrees. You can also write in radians. So those are the three roots of this complex number. We'll just do this much for this video. I'll see you again in the next video.